Hey everybody, this is Mr. Bells again. So this is our first unit on probability. So this video is going to deal with section 10-1 on something called sample spaces, which is how many possibilities there are for the things, and basic probability. So again, these match up directly with the assignments. So the first question of your assignment would be this thing right in here. It says you roll a die and flip 3 coins. The number of possible outcomes in the sample space is. So a couple things that I want you to know. First off, sample space means total number of possibilities. And sometimes they'll ask you to write those down. And sometimes they'll just ask you to do it. So if you roll a die, so a die has 6 sides. So I got 1, 2, 3, 4, 5, and 6 possibilities for that dice. Again, a 1, a 2, a 3, a 4, a 5, or a 6, and then you flip 3 coins. So if you're flipping 3 coins, this coin could end up heads or tails, and this coin could end up heads or tails, and this coin could end up as heads or tails. So when it says the number of possible outcomes for the entire sample space, you just look at those sections and you go, well, how many possible are there? Well, I could have a head here, a head here, and a head here. I could have a head, tail, head, or I could have a tail, tail, tail. So there's a bunch of different possibilities. So what I need to do is simply multiply them together. So there are 6 options here, times 2 options for the first dice, times 2 options for the second coin, times 2 options for the third coin. 6 times 2 is 12, times 2 is 24, times 2 is 48. So there are 48 possible outcomes, and that's what the sample space would look like. Okay, so the next one says you flip a coin and draw a marble at random from a bag containing 2 purple marbles and 1 white marble. The number of possible outcomes in this sample space is, well, flipping a coin, put those down, and then marbles, it says there are 2 purple and 1 white. So again, I'm not going to do all these problems for you, but hopefully what I've done on some of these ones is going to help out with that. So go ahead and give that one a shot. Exercise 5, same thing. Number of possible outcomes. So think about how many there are in each one of these sections, and then tell me the number in the sample space. If you want to write out like what I did, that might help a little bit in terms of it, and then we go from there. Notice on the first one though, it says you roll a die and flip 3 coins. Some of these just say, like this one, you choose a card. A card means you're only picking one out of those possibilities. So how many different options are you going to have? Which is completely different than picking 2. So let's go to this one right here. So it says you draw 2 marbles without replacement. So that's a big deal on this thing, this word called replacement. Because if you replace it, that means the probability is not going to change from time to time. Or if you don't replace it, you're going to have less outcomes. Just think of it this way. Say you were playing cards with somebody and you already have the Jack of Hearts in your hand. Well, the chances of getting another Jack of Hearts are impossible because you already have it in your hand. Now, if you had a deck of cards and you flipped over that Jack of Hearts, and then you put the Jack of Hearts back in and reshuffle them all again, there's still a possibility of you getting that Jack of Hearts. So replacement versus not replacement is pretty big in terms of it. Okay, so let's go ahead and do this one. So you draw 2 marbles without replacement from a bag containing 3 green marbles and 4 black marbles. So I got 3 green marbles, and I don't have a black pen right now, but let's just say I got 4 black marbles, and I'm going to draw 2 of them out. So it says the total number of possible outcomes in the sample space is, and you go ahead and figure out what you believe it is right now, and we'll see what you think. Okay, so I'm going to pause for just a second, and we're going to go. Awesome. So here's what I want you to think about is this. When all the marbles are in there, you have a possibility of drawing 7 of those things out, right? So that would be 7 total possibilities. Now, one of them's gone, and I don't know if it's this one right here, or if it's this one right here, or which one it is. I just know that once one of them's gone, because I'm not replacing it, then the next time that I draw, I'll have 6 possibilities. And then the total number of possible outcomes has to be that product. So that would be 42 possible outcomes for that one. Okay, so here's another one. This one's called The Game Show. And it says a game show airs on television 5 days per week. Each day a prize is randomly placed behind one of 2 different doors. The contestant wins the prize by selecting the correct door. It says, what's the probability that exactly 2 of the 5 contestants win a prize during the week? And this is really where probability gets tough. You have to read every word for it. So this says that exactly 2 of the 5 contestants win a prize during the week. Exactly 2. Okay? So that means I can't have 3, and I can't have 4, and I can't have 5, and I can't have 1, I can't have none. I have to have exactly 2. So what I need to think about is, well, how many possibles are there out of the total number of possibilities? So I'm going to try and show you this without giving you the entire problem as an answer right here. I believe that on each day, day 1, you could win or lose, so there's 2 possibilities. On day 2, you could win or lose. Day 3, you could win or lose. Day 4, you could win or lose. And day 5, you could win or lose. Those are the 5 days that we go through. And 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So there are 32 total possibilities during this stretch. That's the bottom. So we know the denominator is 32. Now the numerator, well, it is possible that they could win, 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 win. That's one of the 32 possibilities. It's also possible that all 5 of the contestants could lose. That's one of the possibilities. However, there are 32 possibilities, and we've only shown 2 of them. So let me give you this one, and that's probably the last one that I'm going to give you. I could win, lose, win, lose, lose. Okay? That is 100%. That's one of the possibilities, and that's different than lose, lose. Let me show you this one. Lose, lose, win, lose, win. Both of those 2 are possibilities that exist that aren't these or these. So those, I have 4 of these 32 possibilities. It wants to know when there's exactly 2 of the 5 contestants win a prize. Well, this one, would you agree there's exactly 2 of the 5? And this one, would you agree there's exactly 2 of the 5? So I know that there's at least 2. What I need you to do is figure out the rest. So go through and think of the different possible combinations that will get you that. Okay? Okay, so the next one says, when 2 6-sided dice are rolled, there are 36 possible outcomes. Find the probability that the sum is not 4. Well, when I have something like this, I would say it would be really good, if I know that there are 36 possible outcomes for this dice, is I would get a chart. Man, if you Google right now, one of the things like a dice chart, it'll show you all the different possibilities for the sum of 2 dice. Okay, so you know that I could get like there's a 1, 2, 3, 4, 5, and a 6, and a 1, and a 2, and a 3, and a 4, and a 5, and a 6. So there's a possibility like this one right here. Let's say it's this one, which is this connection with these bottom 2 things. I'm getting a 5 on this dice, I'm getting a 6 on this dice, and the sum of that would be 30. Awesome. So we know the total possibilities is 36 out of these things. So find the probability that the sum is not 4. Well, is 30 not 4? Yes, so that's 1. And this is where we're going to get to something called the complement. Complement. And a complement really means it's everything but what you want. So instead of me finding out all of these ones, because like 36 right there, that's not 4, that's not 4, that's not 4, that's not 4. None of these ones are 4. There's a whole lot of them that are not 4. What I might want to do is find the ones that are 4 and then subtract that from the total, okay? So would you agree that right here, the connection between 2 and 2, that gets you a total of 4, yes? And 1 and 3 gives you a total of 4, and 3 and 1 gives you a total of 4. Now the question is, are there any other possible combinations that get you a sum of 4? And the answer is no. So if there are 3 that are 4, then there must be 33 that are not 4. Does that make sense? Good deal. So based on everything that I just did right here, you can go ahead and finish up writing the answers into this spot right here, and then try this next problem right below that. Is that okay? Now, it does say fraction in simplest form. So I don't know if it's going to be picky on this, but I'd probably reduce that. 3 goes into both of those, so that's 11 twelfths. 11 twelfths. Okay. Good deal. So these next few problems are going to deal with charts. So it's your ability to be able to read a chart. So this first one, A, says the probability of the person chosen at random is at least 15 years old is, well, at least 15 years old is, let's say, oh, this one's 15 to 24, and this one's 25 to 34. That's 15, that's 15. All of those ones that are dotted are 15. So again, I could add all those percentages up, right? Or I could use the complement. I could find the ones that aren't that and subtract that from 100%, or subtract it from how many possibilities there are. But this one's already in percent, so we can just use that. Okay, so hopefully you follow that 10 matches up just like this last one just did. We're going to move through here again. Again, my goal is not to just give you the answers here. My goal is for you to be able to understand the math based on what we're doing. Okay, so this next one is a problem that says something about the Gulf of Mexico. So it says the map shows the length in miles of shoreline along the Gulf of Mexico for each state that borders the body of water. What is the probability of the ship coming ashore at a random point in the Gulf of Mexico lands in the given state? So it's saying we could hit on any one of these things. And it says round your answer to the nearest whole percent. Well, what I simply have to do is, if I want to know Texas, well, Texas is 367 out of the total. Well, the total is whatever their border is, their shoreline right there. So I think you can probably do that with your calculator. Simply add those up, fill in each one of these things for Alabama, Florida, and Louisiana. Let's go all the way down here to the next one. It says in exercise 15, you roll a 6-sided dice 60 times. The table shows the results. So what does this chart mean? Because I can't really answer questions until I know what the heck the chart means. That means that of those 60 throws, I threw a 1 11 times. I threw a 2 14 times. I threw a 3 7 times, a 4 10 times, a 5 6 times, and a 12 6 times. And you're like, whoa, look at that. I got more 2s than anything else. And this is called experimental probability, because experimental probability is the results from an experiment. Does that make sense? Okay. And then there's another probability, this one right here. It's called theoretical probability. Theoretical. I'm going to abbreviate a little bit right here. Theoretical probability is what should happen. What should happen if all things are equal. Okay, so, I flip a coin. I should get heads 50% of the times. I should get tails 50% of the time, right? If I roll a dice, I should get a 4 1 out of every 6 times. I should get a 6 1 out of every 6 times. I should get a 2 1 out of every 6 times. However, when we do an experiment, I could flip a coin right now, and I might not, if I flipped it 10 times, I probably wouldn't get 5 heads and 5 tails. Now I might, but I might not also. It might be 4 heads and 6 tails. the more times you do an experiment, the closer it should get to theoretical probability. And if we were in class, we would do all kinds of things. We can roll dice and flip coins and spin spinners and all kinds of things on our calculators right here. We're starting pretty basic right now. So go ahead and you put, it says the number for which the experimental probability, one of these 6 numbers, of rolling the number is the same as the theoretical probability. So my question is, which one of these ones should be correct? Should it have been that everything was 14? Should it have been that all of them should have been 7? Should it have been that all of them should have been 10? What is it if we roll it 60 times? And I think you should be able to figure that one out. Go ahead, give that one a shot. Okay, so moving on. So this says a bag contains 5 marbles that are each a different color. A marble is drawn, its color is recorded, and then the marble is placed back in the bag. This process is repeated until 30 marbles have been drawn. The table shows the results. So what happened was the white marble was drawn 5 times, a black marble was drawn 6 times, a red marble was drawn 8 times, a green marble 2 times, and a blue marble 9 times. Now notice it says there are 5 marbles in the bag. So if there were 5 marbles in the bag, each of them should have been drawn the exact same number of times, but it wasn't the case. It's like the poor little green one was only drawn twice. Now we're going to assume that they were all the same size too, and there were no chips or anything on the marbles to make one of them stand out compared to the other ones. So it says the marble cover for which the experiment probability of drawing the color is the same as the theoretical probability is. So which one should it have been? Hopefully you guys understand based on the last one. It should have been black 6. Why? Well, we did it 30 times, right? There are 1, 2, 3, 4, 5 different possibilities, which means each of the marbles should have been drawn 6 times. The red was higher, or greater probability of being chosen in this experiment. The blue was a greater probability of being chosen in this experiment. Theoretically, all of them should have been 6, so black's the only one that works out. Okay, so we're moving on, and this one I got a spinner again. So it says refer to the spinner shown. The spinner is divided into sections with the same area. So all of these are the exact same section. You spin the spinner, it could land randomly in any of those sections. It says what's the probability that the spinner stops on a multiple of 3? Well, a multiple of 3 is a number that is evenly divisible by 3. So if we check right now, 6 does 9, 12, 15, 18, all divisible by 3, 21, 24, 27, and 30, all divisible by 3. 4, not evenly divisible by 3. Okay, so based on that, I believe that you can go ahead and answer those 2 questions. Next. C says, why is probability in part A different than the probability in part B from those different sections? Again, it's one, sorry, there's a video's better loaded. I believe that you can answer that one pretty easily based on what we've just done. Which takes us to our final problem in this one. Yay, you guys can do this. It says a survey of 2,237 adults ages 18 and over are asked which sport is their favorite. The results are shown below. And it says pro football, baseball, college football, auto racing, other. I should put in there. It's probably volleyball, right? Yeah, for those of you who know, I've been a volleyball coach here for about 20 years, so that'd be big on my thing. But who knows what the other is? Maybe it's ping pong or something else. So 2,237. I believe if I added up 805, 291, 291, 179, and 671, add up all of those things, that would equal 2,237. And it says, what's the probability that an adult chosen at random prefers auto racing? Well, where's auto racing? Auto racing is that number. So remember, probability is success for whatever you want to have happen, in this case, auto racing, divided by total number of possibilities. And that's the last one on that. So that again that's section 10-1. Hoping my little video helps as you go through these ones. Please give it a shot. Again, this is Mr. Bells. Peace out.